All right, so in this segment, we're going to talk about writing double replacement reactions, otherwise known as metathesis reactions. And so double replacement reactions is where you have two compounds, one compound, another compound, and they're going to switch partners. In other words, the metal of one is going to end up with the non-metal of the other. And so I've tried to signify that with the two different colors. A and B being the cation and anion of the first compound, and M and N the metal and non-metal, the cation and anion of the second one. So how do we figure out the products if we just have the first part? So if we're given the first part of a reaction, how do we figure out the products? We get the reactants, we need the products. We switch the metals with who they're with. And that's the easiest way to do it, so that you always get the metal first and the non-metal second in each compound. Okay, so here I had sodium sulfate and barium chloride. And if those react, the products I should make or could make are barium sulfate and sodium chloride. So I switch the two. I'm going to worry about if I have the right formulas only if I figure out if a reaction really happens. So the next question is either product a solid? Or is it a molecule? So if in the process here, if I'd made water, H2O, I would have made a molecule out of an H on one thing and an OH on another, two ionic parts. But most of the time, what we're going to concern ourselves with is solubility. Are either of these things a solid? In other words, they don't dissolve. And how do I know that? Well, I have some rules. And the rules that are in a lot of different places have many exceptions and lots of detail. I tried to boil it down to a very simple overview. And so there are things that will always be aqueous. And there are a few lithium exceptions we're not going to worry about here. So pretty much anything in that first column, any alkali metal, it's in the first group 1A. No matter what it's paired with, it's going to stay dissolved. It's not going to stick tightly to it and come out of a solution. Also, anything that is attached to ammonium will stay dissolved. It won't attach tightly. It'll stay dissolved in solution and dispersed in water. Any metals that are attached to nitrate, chlorate, or perchlorate will also pretty much always be dissolved. Now on the other side, I've got all the things that will become solid, except when they're paired with something from over here. So carbonates, there are a few exceptions. Most phosphates, chromates, and most sulfides are insoluble, except when they're paired with this. And hydroxides as well, although there are a handful of hydroxides. We're not going to worry about them for the purposes of my course, but out there some of you may be concerned that there are some hydroxides that are slightly soluble. Okay? Now, the other two ions I have down here, chlorine and sulfate, for the most part, they're aqueous, except when they're paired with just a few select things. For chlorine, it's silver, lead, and mercury. For sulfate, it's those same three heavy metals, and also the second part of the lower part of the alkaline earth metals, the second column, group 2A. So calcium, strontium, and barium. Okay, so we have rules that tell us whether or not we're going to get a solid. And if we get a solid, that means that two of the ions that were free-floating, swimming around in the water, now meet each other, stick together tightly, and go to the bottom of the test tube. They become a solid. They don't stay in solution. That means a reaction has happened. So, in this case, we did have something that was a solid, because barium sulfate, according to that rule, is a solid. So we do have a reaction. So that means that we have to get the formulas right and we have to balance it. So we have a complete equation. So how do I write formulas? Again, I go to the chart, the periodic table, and see which column it's in and what kind of an ion it would form. So barium is in group 2A, it has 2 electrons to give, it becomes +2. Sulfate is a polyatomic group, is a 2- ion. That's something you either just need to look up or know. Together, because one's +2, one's -2, I only need one of each to end up with a neutral compound. And this indeed is the solid. Sodium and chlorine. Sodium is in the first column, group 1A. It's an alkali metal, +1. Chlorine's a halogen. It's in group 7A. It has 7. It only needs to take 1 to have a full outer shell. And so, again, I have equal charges. I only need 1 of each. So finally, now that I have proper formulas for the two things, and notice I didn't take the 2 for the Na or the Cl from the reactant side, because those were the formulas of how they were with other things. But together, this is how they are. And so the last thing I need to do is balancing. I started out with sodium sulfate, Na2SO4, and barium chloride, BaCl2. I get two products, BaSO4 and NaCl, and the one thing I notice is that I don't have the same number of sodiums or the same number of chlorides. And so I need to balance it. I need to put I need to put a coefficient in front of sodium chloride. So if I put a 2 here, that takes care of all of it. Now I have 2 sodiums, and I started with 2 sodiums. And 2 chlorines, I started with 2 chlorines. The barium, I had 1 and ended with 1. Sulfate, I had 1 and ended 1. Now it's balanced. And in this, the barium sulfate is my solid. It's my precipitate. Therefore, this reaction